So I will show you Moscoviense Basin as site for future lunar missions, and we move on to the next slide, please. The far side is only explored with remote sensing, except the Changi 4 landing site, which lies into the South Pole 8K basin. So therefore, we have no samples from the lunar far side or lunar poles, which is quite difficult. We have only few sample sites on the moon, and all of them are, as you can see here on the image on the right side. On the near side, the blue dots mark the Apollo missions, the red the sample return missions carried out by the Soviet lunar mission program, and the green circle marks the Imbrium impact event, and the outer green circle marks the threshold line to which the ejector could have flown. And as you can see, possibly all of the Apollo mission samples could be biased by the formation of Mare Imbrium, and we wanted to analyze if Maria on the far side would be also influenced by the formation of Mare Imbrium. So our study goal was to create a new geological map for the Moscoviense Basin on the lunar far side. So can you please move on to the next slide? So here is Mare Moscoviense. It lies at around 25° north and 146° east. It is one of the most prominent features on the lunar far side, and as you can see on the digital elevation model on the right, that clearly visible are the three ring structures of the basin itself, the central ring, part of the central ring in the inner of the basin, the second ring, which is marked by the arrow on the right side, and the third ring of the basin, which is marked by the arrow on the left. And as you can see on the next slide, this is a geological map we've come up so far. And one of the interesting points is in the upper left of the map, where you can see this lightish blue part, which marks an Imbrium crater chain, and with numeric modulation, we could trace back this crater chain directly to the formation of Mare Imbrium. And we also mapped out the rings of Moscoviense itself, and found out that some of the craters inside Moscoviense are slightly younger than previously thought. We found one crater with Copernican age, several with Eratosthenian age, and also, as you look at the basin floor, that it is more diverse than previously thought. And move on to the next slide, please. Our results so far are that the formation of Mare Imbrium affected also the basins on the lunar far side. The crater floor of Moscoviense itself is heavily cratered. Nevertheless, the crater's floor is relatively smooth, which would be good for landing on the crater floor. And we found also some deep penetrating craters which excavate crust material, which would be good to analyze for future lunar missions and could help to unravel the mystery of the lunar dichotomy. Also, we could gain new insights into the geological evolution of the moon, and we observed multiple phases of activity inside Moscoviense. And with that, I will thank you, and I'm done.